This video shows how to test the normality assumption as a requirement for the one-sample t-test in R. Since we only have one variable, the test variable, this is what we test for normal distribution. I'll show you 3 sufficient ways and with other words of caution, especially for number 1 and why you should rather opt for numbers 2 or 3. First, you can conduct the Shapiro-Wilk test. Its null hypothesis is that the variable being tested is normally distributed. You can use the Shapiro.test function in R and within it your test variable. For example, the variable h of my data frame called df. If the p-value is below a predefined threshold, you have to reject the null hypothesis of normal distribution. This is the case for my variable h. Please be aware though that with larger samples, the power of the Shapiro-Wilk test increases, and negligible differences will lead to a rejection of a normal distribution. Information on that phenomenon can be found in the sources in the video description. Second, an ordinary histogram can be used to test for normal distribution. Simply put the test variable within the hist function. What you are looking for is an approximate bell shape of the column heights. Note that there may be small deviations that will not hurt the assumption. In my case, you can clearly see a distribution skewed to the left, hence no normal distribution can be observed. Third, a QQ plot can be used. In order to plot it, you put the test variable within the QQ norm and subsequently the QQ line function. The dots represent the observations and the line the perfect normal distribution. Therefore, the distances between the dots and the line should be minimized. Again, there will be acceptable deviations, especially on the edges of the distribution, meaning the upper right hand corner and the lower left hand corner. For my test variable, deviations can be observed throughout, resulting in a non-normal distribution. If you cannot observe an approximate normal distribution, you should use the one-sample Wilcoxon test instead of the one-sample t-test.